que va vale, de los riesgos que va a implicar para todos nosotros, de los posibles beneficios también, y un poco de qué podemos hacer a nivel de políticas públicas para remediarlo y demás. Entonces ahora mi compañero os va a introducir un poco el grupo de AI Safety y después empezará la charla con el ponente. Así que, bueno, espero que lo disfrutéis.
Well, I'm gonna do the talk in English. Everyone is fine with that. ¿Cómo paso de diapositiva? ¿Cómo paso de diapositiva? Sí.
En el mando para que un botón abajo.
¿Ah?
Pon la presentación, ¿no?
Well, this is the topic we're gonna cover, the welcome session, the Adrià talk, and then some future activities we're gonna announce, and in the end, just networking and some food. So the welcome session. Well, what's this AI Safety Barcelona? Who we are? Just our mission is just focus in tackling the AI risk that comes from the development of uncontrolled AI. And we just work to develop the AI in a safer way and in a responsible way, protecting our future while we are encouraging also innovation. And this is possible because of the team, where our team is from 6 people, which are Mel, and Darcy, and Marcel, and there are a couple of our team that is not here. And we're just a combination of researchers, students, community builders that is working together, addressing the risk in order to make this possible. So what are our objectives? Our first objective is just reaching awareness of the risk that AI can pose doing just what we're doing, and just explaining to people the risk that AI could cause. In the second objective is just education, just giving a pack of skills to people that want to get involved in this industry. And we will do in the future workshop and some training opportunities to just enhance your skill sets. And in the end, just the growth of the community working in AI safety. We just encourage people work in this industry because it seems really prominent and it's growing really quickly since the AI is also growing quickly. So, well, of course, having fun is the most important. Well, how can you get involved with us? Join our events. We will do regular events in the future. And also the activities that we will announce by the end of that talk. And you can also follow us on Instagram and look our website if you want to get updates of our events and activities. So let's go to the Adrià talk. Who's Adrià? Adrià is right now working in FAR.AI, focusing in mechanistic interpretability. Some of his key project is just automatic circuit discovery. It's just mechanistic interpretability research. He did research previously in Red Bull Research, and about his academic background, he did a PhD in Cambridge about Bayesian neural networks and a master in Oxford, and he was a bachelor student here at UPF. Some of his goals, I think, is just working in AI safety. Also, he just doing mentoring in maths last summer. So, well, let's go with Adrià's talk.
And maybe just quickly mention after the talk, the idea is that we can hang around and have some.
Yeah, the networking. Yeah, well, we'll announce activities and then the network. Yeah, okay. So go ahead. It's all yours.
Please enable screen sharing so I can share my talk. Hello, everyone. Thank you for having me here. I will yeah, I will hopefully be able to share my slides. Ah, there you go. Now they are. I was going to start anyways, but here we go. Okay. Everyone can see my slides. It's good. Okay. Thank you. Okay. Hello, everyone. My name is Adrià, and I'm going to talk about something that I'm not quite an expert in, but I do dabble, which is political or policy interventions for safe AI. And I guess I'll also explain a bit about the risks in context, but not talk very much about the benefits, even though there are many. And yes, and these are my views. I kind of do represent FAR.AI, but kind of like a university. The FAR.AI is a nonprofit that does research and education into safe AI that's beneficial for society. And we just have a bunch of researchers, and we disagree with each other all the time, including in public. So yeah, anyways, that was the disclaimer. Thank you for introducing me. I had a brief self-introduction, maybe to make myself a bit more relatable. So I'm from Rubí, which some of you may have heard about. It is very close to Barcelona and El Vallès. And I also studied in Pompeu Fabra from 2012 to 2016. And I got interested in general AI at that time and making it safe. And I thought I would dedicate my career to this. And here I am doing that. So it went pretty well. Did a PhD in Cambridge, and yeah, my reasons for talking about this briefly is that you too can do something about AI, and perhaps you should as well. And there are many opportunities to get involved. Perhaps the organizers will tell you more, but I also have a list of fellowships that you can get to work at straight away. Like you can apply and do some research on the topic, be it technical research or governance or both. And I can share that, and I'll also have it in my final slide in case you guys are interested. Okay, so first of all, what am I going to talk about today? I'm going to talk about generic policy interventions against accidental catastrophic risk from AI in part 1. And then in part 2, I'm going to talk about FAR.AI and specifically my work and how we are trying to address this. It's a very small slice of what everyone is doing, but it's the one I know best, of course. Yeah, so some of the things I'm going to talk about are unilateral interventions that oops, yes, yes, okay, here. That people might use to make AI safer, some legislation that has passed, and some international coordination that people are trying to do. There are many more interventions in AI governance that I do not have the time to talk about. And then at FAR, the most important things we do policy-wise are we run this alignment workshop, which is a way to build the field of AI safety within academic machine learning conferences, so that the people that are researching how to make AI better also think have a venue to think and present work about making it safer. And I also present some of our technical research, mostly mine. Things that are not in scope in this talk, even though they're very important, is misuse from AI. So a large amount of the risks that come with advanced AI are risks of people misusing this AI to do things that are bad, such as surveil the population better and oppress people. Or with a very advanced AI, maybe you can know how to design and synthesize a deadly pandemic, right? Like these already exist, right? So maybe all you need to do is get the DNA and synthesize this. There are companies that also do this online, though they have screening for this, right? But maybe with some biology knowledge, you can do this yourself or bypass those. Or maybe if the military uses AI in certain situations, it could also lead to risk escalation of a war and nuclear exchange. But instead of focusing on this, which there's many problems, I will only focus on accidents. And also, I will also not focus on accidents which are not existential, even though they're very bad. For example, if a military AI which decides to target of a missile kills some civilians, that is very bad. But I'm not going to talk about but I think like most of the interventions here are like application specific, or they're about improving the robustness of AI systems for which there are commercial incentives. So I think it is a problem. It is a big one, and we should research it. But I personally haven't studied it as much, so I'm not going to talk about it. Okay. So what are some of the things we might do to make sure AI is safe? And to understand this, first we must understand the problem and the threat model. Okay, so what could go wrong with AI? So I'm focusing here on existential risk, which I define as the risk of human extinction or massive loss of future potential of humans. So and basically the threat model here is that AI takes over, and then we can't decide what it does anymore because it does what it wants. It is smarter than us, so we can't really stop it either. One or many AIs, it doesn't have to be one of them. And therefore, humanity is no longer in control of its own future. Now, this AI is in control of its own future. Similar to how gorillas, as big and strong as they are not in control of their own future. We are in control of the gorillas' future. And if we wanted them gone, they would be gone. If we want to use their forests for something else, they would have to, deal with it. Fortunately, we don't, and well, like we do some amount, sadly, but yeah, at least there's some caring. But anyways, artificial intelligence might behave the same towards us. And here I put a picture of Geoffrey Hinton, who now has a Nobel Prize as well as a Turing Prize. And recently he retired from his position as AI advisor at Google, partly because he's kind of old and, you got to retire, but also partly because he's now very worried about AI taking control when it becomes more smart than humans. And his quote that I think encapsulates this very well is that there are very few examples of a more intelligent thing being controlled by a less intelligent thing. Maybe one of the only examples is children or pets influencing the behavior of adult humans. But this is not very strong control. Like at the end of the day, children don't tell parents what to do most of the time. It's the other way around. So we could find ourselves in the same situation. How can we prevent this? Well, the easy way, okay, the technically easy but socially very difficult way is to not build AI. And this is socially very difficult because, well, AI would also have lots of benefits in invention and science and commercial applications, automating things we don't like. So there's enormous social pressure to build, so enormous social commercial pressure to build it, enormous competition, like international competition pressure to build it as well. Perhaps an easier sell, even though it is a lot technically harder, is to build AI that is known to be controllable and safe. So for this, we need to research AI safety and control to understand how to make it controllable and safe. We need to carefully apply these techniques to any new AI that we have built. We need to test it for safety and controllability and make sure that it is actually safe and controllable and that the techniques have been applied correctly. And we need to monitor on an ongoing basis AIs that have been deployed, etc. So all of this has a cost. And a lot of this cost is money, but a lot of it is also development time, right? So if you need to make sure that the AI that you've built is safe and controllable and tested, this will add weeks or months to your development timeline of the new AI. And taking longer to develop it is not what the people developing it want, right? So many commercial interests, like many commercial companies, have an interest in getting there first and having the best product so that people buy their AI and not someone else's AI. There's also, great power competition between the countries. If AI is so powerful that it could cause an existential risk, well, then it's also very powerful to do many things, including give you decisive advantage over your opponents in government affairs. So all of these forces make it difficult to actually, take the time to make sure AI is safe or not build it. But there are some things we can do. And here's some background. I call this fortunate trends. I'm not sure they're fortunate, but they are trends for sure. One of them are scaling loss. This is the discovery that reliably neural networks that are trained with more computation, more parameters, and in this case, the x-axis here of this graph is the total amount of floating point operations used in training a particular AI system. And on the y-axis is the total performance in a very difficult language model benchmark. And we can see that reliably bigger models are much better at this, even though in many cases they use basically the same techniques. So this means that, well, you know, on the negative side, this means that we have a very clear path to more and more powerful models. It's not clear that they will go all the way to super intelligence and, you know, be worrying in the loss of control sense that I talked about earlier. But it's very possible. So yeah, just by more investment, we can get there, and that's dangerous because it means that we can get there soon because people know what they're doing. But it also has a positive flip side, which is that AI is very expensive. And to actually get these dangerous models, you need to spend a lot of money on chips, on energy, on land for your data centers, on broadband, on water, etc. And so these are like large projects which are hard to do in a hidden way. So, you know, law enforcement within a nation and international treaties can monitor it, for example. Another trend, which I do think is quite fortunate, is that it turns out that the same recipe works for improving performance with very few changes. And this recipe is, we spend a lot of compute on just predicting the next label of some kind of data, be it images, text, videos, whatever. We just predict, you know, what comes next. What's the next frame of the video? What's the next pixel of the image? What's the next token of the text? And that, you know, gives the AI a character that is mostly, you know, just reproducing this data instead of trying to hyper competitively win at a game, which is what we thought AGI was going to look like in 2018 or earlier. So that's fortunate, but it may also come back. So companies are now trying to train agentic AIs that automate things better or do the job better by using this reinforcement learning procedures. And so they might become optimizers trying to do something again. And that is actually what my research is about. I will come back to it later. Yeah. Okay, so given this landscape and the problem of loss of control from super intelligent AI, what can we do about it? I'm going to talk about some policy solutions or proposed solutions, basically, that I've selected for popularity and perhaps how well I think they would work. Yeah, in some order. Okay, so most of the solutions, in my opinion, fall into these two camps. One of them is to buy time. So, you know, because making sure that finding safe AI techniques and then implementing them in a correct way takes a lot of extra time. One thing we can do is buy more time until we get the super intelligence to, you know, get all of this correct before we have to apply it. So one of these proposals is to pause AI development nationally or internationally, and there's some protest movements in there. That's a very straightforward way to buy more time if it works. We could have an international AI project, in which case there's only one project that is trying to make AI, so they don't have to worry about anyone else getting there first, so they can take their time. Or we could stack the deck in favor of the front runner of the AI race, so that, you know, they have more buffer compared to the second player, and they can get there safely. So this type of solutions, because the front runner is an American company, probably OpenAI, but it doesn't have to be. We don't really know. This kind of solution is very favored by, I guess, people in those companies, but also the national security establishment in the United States. So the intervention here are things like restrict the export of chips that are necessary to train cutting-edge AIs, put restrictions on chips that make them more trackable by law enforcement or international treaties. I guess the international treaties part here is also like doesn't rely on the top company being American. Or we can incentivize safety by making it commercially useful to have safer AIs, or by banning AIs that are clearly unsafe, and so forcing companies to invest in safety. Yeah, interventions to not build AI or build it later. For example, Cambridge professor David Kruger advocates for not building AI. Few other people do, but I think it's worth listening to at least. There are various movements and nonprofits advocating to build it later, and this is kind of like bolstered by public opinion. So this is a poll from the US only. Again, I guess I live there and many of the orgs are from there, so it's like easiest to get that kind of data. Most people are more concerned than excited about AI developments, or we're in 2023. Another intervention that I think is very sensible is heavily advocated by Professor Gillian Hatfield, here pictured. And the intervention is that companies should register models with national or international agencies. And this is like the basis of all regulation that we currently do. You know, like first we need to have a database of the thing to regulate, or like a list of, you know, projects or whatever, and then we can come up with rules for them and apply them, right? So for example, in basically every jurisdiction in the world, if you want to have a company, you need to register it first. And then, you know, like now the state knows to tax this company, etc. And we can work out the details of what to do with the AIs once they're in this registry, right? So like the first step here would be to just register the models. And one law that has taken this step, for example, is the EU AI Act. So the European Union, I think in 2022, the European Parliament passed this very comprehensive law regulating the development and deployment of high-risk AI systems or general purpose AI systems. And one of the requirements for high-risk systems is registration. And one of the requirements for general purpose systems is to document the model well, so that the AI office, which is another institution that comes from this law, can request the documentation. And this legislation is very good at, I guess, slowing down the creation of existential risky AIs, because they have specific provisions for them, and the way that they capture AIs that could pose an extra risk are, you know, it is either highly capable at benchmarks, or the UAI office thinks that it would be if tested, so the company can't get around it just by not testing it on the benchmarks. Or it was trained with more than 10 to the power of 25 flops in total. And if you recall from earlier, you know, AIs that are trained with more flops are reliably better at benchmarks and things. So this is a way to capture that as well. They're coming up with a code of practice. Let's keep these. And yeah, some interventions that people have proposed to preserve the leading lab's lead. So the theory here is that if there's an AI race and the first player has more time to invest in safety before the second player catches up, then we will be able to invest in more safety overall in an AI. And so, yeah, so the US Department of Commerce has restricted exports of GPUs. People have proposed tracking chips by on-chip measures. People have also proposed like improving the security of the leading project, for example, by putting it under the government. But yes, many of these actions would in fact give more margin to the first player, but they would also perhaps make it clear to other players that they need to race to catch up. And so it's unclear to me what net effects they would have. So another approach, which I will talk by way of talking about the Safe AI Forum's work, is international cooperation. So we could have some international treaty that says that only certain labs can develop AGI, and then their safety protocols are mutually measured by the respective countries. Or there's one international project, and then the safety protocols there are clear and everyone collaborates, something like this. So towards that, the Safe AI Forum, which is another nonprofit, which is very closely associated with FAR.AI currently, runs these international dialogues on AI safety. And these, they put together in a room Chinese scientists and Western scientists to like decide on, you know, consensus resolutions for how AI should be developed. And yes, there are some very big names. And for example, one of my favorite consensus statements that they came up with was in this like meeting in Beijing a long time ago now. I think about a year and a half, maybe it was late 2023 or early 2024. I don't exactly remember. But the proposal is that we should have international laws that get passed in every country that make it so that if you know your AI that you build displays any of these capabilities that everyone agrees are bad, then we should shut it down and delete it. So the first one that they come up with is autonomous replication or improvement. So the main way that AI can get super intelligent is by using its small edge in intelligence in humans to like improve development of future AIs or give itself more compute. So if it replicates and copies itself to other servers so that it can think more without explicit human approval, that's a huge red flag, and we should really stop this AI. Seeking power, so trying to obtain influence over the company, obtain money, etc., without explicit instruction. Assisting weapon development for nuclear weapons, chemical, biological. This is also a thing that would be really bad. Partially because then terrorist groups could get their hands on the AI and do it, or massive cyber attacks, or deceiving human operators. If any of these things happen, the IDA's meeting proposes that the particular AI that did it or the development program should be stopped. So this is not any kind of law or anything yet, but it's like an impulse for like what a law could look like. Yes, finally, I'm going to talk about FAR's work. So FAR is a nonprofit whose mission is to ensure AI systems are trustworthy and beneficial to society. And we have three main pillars of things we do. One of them is we, like the FAR Futures pillar, focuses on building the field of AI safety and governance. So we help organize the IDAs, the thing I just talked about, as well as the Machine Learning Alignment Workshop, which is for academics at major machine learning conferences. Another pillar is FAR Labs, which organizes academic workshops, events, and provides a working space for the safety community in the Bay Area, where a lot of these things are located. SFS San Francisco here. And one of the things that they have done, which I think is pretty cool, is they organized this workshop and wrote a consensus paper about AI that is provably safe, so that not only have we tested it and it seems that it's kind of safe, but we actually can mathematically prove that it follows some model or it has some guarantees. Now, I don't necessarily agree that this is possible, but I think it's good that people talk it out and are thinking about it. And so this is one of the examples of good things that FAR Labs is doing. And the other thing that we do is technical research. So FAR Research is the third pillar, and we incubate and accelerate a portfolio of AI research. And this is where I work. So some of our research is about scaling laws for model robustness. So just as we have scaling laws of when the model gets bigger, how much better it's going to get at benchmarks. we also can check how much better will it get at being robust with larger size. Another thing we can do is investigate how effective it is to train against lie detectors for models. We think it's not going to be very effective, but we really should check. And finally, what I focus on is detecting goal-directed behavior and preventing it. So if we manage to get an AI that doesn't really have any goals and just kind of does what you ask it, but not for very long, it doesn't act autonomously or like things in long-term timescales. Maybe this could be really useful, but not very dangerous. Because if the AI doesn't have any goals, it doesn't have any reason to take over and take control of the future. So I don't have a lot of time left, so I will only talk very briefly about my work on this. You can find it in archive, but I'll skip this video. The main reason, the main thing we're trying to target is to find the goals and understand how the goals are implemented for neural networks that have learned to solve a task, but not by heuristics or by just kind of doing stuff, but by explicitly thinking of what they want and how to get it and how does the world work in order to get it. So classically, let's use this slide. Classically, we think of explicit planning algorithms as something that has, like you have these algorithms that have the game tree, right? So the game tree is kind of the model of the world, the set of actions that you could take and the set of outcomes that they would have. And then the search algorithm looks for all the possible futures it can and how good would they be according to the goal or criterion, and then takes that, right? So we're trying to look for that in AI. And yeah, results are we trained a neural network to play Sokoban, which is a puzzle game. It looks like this. Yeah, it looks like this. So the goal is to put the boxes on the goals. And then we find that this AI naturally takes time very often at the beginning of the episodes to perhaps think of how to solve it before actually solving it. And we also, do a bunch of other experiments, but the main other thing we do is we are able to, hold on, this is the one. We are able to predict using the internal activations of the AI and just linear regression, what actions it will take. So these green arrows here are directions in which the agent will move, and they have been extracted from the neural network's cognition with the probes that we developed, in collaboration with a Cambridge master's student, Tom Bush. Yeah, we developed these probes, and then they can predict the future actions of the agent. And we can also intervene on them to make the agent take the actions that we want, right? So these are the actions that the agent takes by default in this custom level to put the box in the goal. But by setting the value of these probes to be higher, we can get it to have another plan instead. So in this case, go left and up, and it actually does the thing. Yeah, okay, and I will skip the rest because I don't have time, and we can get it to play much bigger levels than it was trained with as well. And yeah, that's it. So for this particular work, the conclusion is that we did get a neural network with planning capabilities, and we were able to find the plans in it. And we were able to, intervene to change the plan that it currently considers best. So we're pretty sure that we have found the plans. And we also found that it learns to think for extra steps at the beginning of the level to get a better plan to solve the level. And yeah, I'll skip off this. Our goal with this work is to be able to tell whether a particular advanced AI has goals. And then if it has goals, we need to be more careful or find a way to perhaps remove its goals while keeping its capabilities. And yes, as a recap, that's part of the work we do in FAR.AI research to prevent catastrophe from AI, and it's one of the technical interventions. And that's it. Thank you very much for your time. If you have any questions, please let me know. This is the list of fellowships that I promised early on. You can take a picture if you want.
Anyone has some questions? Well, any questions? No? So I may have a question. Do you think that current evaluations can in some way just evaluate the true potential of an AI model?
What do you mean by the true potential?
Just kind of like the dangerous capabilities of a model. Can they spot it?
Yeah, that's a good question. I think I think we can get pretty close, but no, not entirely. I guess so. I think we're pretty close to evaluating the capabilities of an unaltered model, right? So we have like pretty decent scaffolding schemes. So like schemes where like we add more prompts and let the model think for longer and then like propose new prompts or something about a task. And we can, I don't think we'll see a huge amount of innovation there. And so we already have quite good ones, and we can predict how well the model does this. Or like how well is the model able to do tasks using this thing. But I think it's possible that we will see in the future techniques or like ways of fine-tuning models that can elicit a lot more capabilities out of them than we currently can with evaluations. But yeah, I don't know. I don't think that's too likely, actually. I think like mostly we'll just get more capabilities from bigger models. So I think for capabilities evaluations in particular, our methods are pretty decent.
Thank you. Oh,
Yeah, thank you.
Dan?
Can
Can you hear?
I can ask, and you.
Yeah, okay.
Yes. How is the planning you referred to is different from like next token prediction? Like what is the difference in planning steps and action steps?
What's different between training step?
Planning.
Planning.
Yeah.
Planning steps and what steps? Sorry.
Step.
And
Action.
action step. What's the difference between planning step and action step?
Right. You mean in the example that I gave? Yeah, that's a good question. I didn't really go into it, but let me go back to that video. That's the one here. So there's no difference, okay, except that these actions don't change the state of the world in an irreversible way. Right? So here, like, in some sense, the trading signal for this agent is that it needs to solve the puzzle. So that gives 10 reward. And then it also gets minus 0.1 reward for every step that it spends on this, right? So it needs to solve the puzzle as quickly as possible, right? And for this, any action that's not pushing a box is a wasted action in some sense, because you're just getting minus 0.1 reward for nothing. But it actually learns to do a bunch of actions that, like these steps, okay, this is going very slowly, but all these steps that we highlight as like planning steps are steps in which it's taking actions that do absolutely nothing to advance the state of the puzzle. So it's just moving around, presumably to gain more time to think. I think in this case, the evidence we have for that is simply that like this happens mostly at the beginning of the episode, and also that we can substitute these planning steps by no-ops. So if instead of letting the neural network take an action, we make it take a no-op for as long as the cycle lasts, then after all the no ops, I think 80% of the time, it just continues with the level without doing any more, walking around. So it doesn't seem like these actions serve any purpose other than delay. And the reason that we say it plans for these amount of steps specifically is that this is the last step at which it comes back to a state in which it already was before, right? So everything in the middle, it's like a cycle in the state space. So everything in the middle, you could cut it out and it would still be a valid solution. Does this make sense?
Yeah, thank you.
Yeah, check out our archive if you're interested, and feel free to email me. I'm very happy to answer questions.
Okay.
Yeah, my question is, if he thinks that in the next decade or so, the big players in AI will continue to be private companies, or maybe states will jump and maybe they will take control, and how does that affect the government of AI in particular?
Do you hear it?
Not very well. Can you repeat the question for me, please?
Well,
Do you think that in the next decade or so, the big players in AI will continue to be private companies, or maybe states will take over and control it?
Yeah. Well, for starters, I think it's going to be less than a decade till we get super intelligent AI. Probably. I'm of course not entirely sure. Whether there will be companies or states. Yeah, I don't really know. I think perhaps I think it's hard for a state to get involved within the next 3 to 4 years, for example, or it just takes a while to move the whole machinery. Though maybe if they believe that, or I don't know, if the United States believes that it's at war or something, then it might mobilize pretty quickly, but I don't really know. Yeah, I guess I would expect it to be companies, or if it's a state project, it'll probably absorb some companies. So it won't be like a completely new project, is my guess. But I don't really know other than that. Sorry.
any question?
Somewhat related question would be, Adrià, you talked about international cooperation and the importance you give to that. So the question would be, how close do you think we're currently about a single international treaty or project to regulate AI? And how far away do you think we are from reaching a consensus?
Yeah, that's another very good question. I mean, these things move pretty slowly, right? Like international negotiations and stuff take a while. I think there are some items of consensus, and there's already a lot of governments currently have these, AI safety institutes, right? I think in the Seoul Summit on AI that happened a few months ago, I think 10 countries or so committed to having an AI safety institute and joining this network. None of these is China for now, but it's likely that if they spun up their own safety institute, they would also, join the network. So I think at least we're pretty close by international standards, which might just mean 2 years from having consensus on what it constitutes to have safe AI, and maybe what the research, what the responsible research proposals, or the thing that regulates internal companies, whether they will build a model or not. Maybe we'll have a decent consensus on what that should be. But yeah, I don't know how far we are from a say international project. People are already advocating for this and advocating the governments for this. And I guess things can sometimes move very quickly if the people in charge are invested. For example, in the UK, Rishi Sunak set up the AI Safety Institute in just a couple months, or like, you know, they just authorized it for a lot of money, and then people joined and then did it. And it just took a few months, which is, you know, pretty quick for government standards. So maybe at that point people can come to agreement quickly, so it will only take a couple years, but I don't know if it will happen at all, I guess. Yeah, I don't think I answered your question, but I also don't think I can. Sorry. These are my thoughts on the matter.
Yes, go ahead. Yeah.
Can you hear me?
Yeah.
Okay. I have one question. Well, thank you for your talk. Like, how can you know if the model is trying to deceive someone? How can you? Is it any different from hallucination from the model? How can you know the intent behind some model? That's it.
I agree that these, like, we don't really have a way to know this in general. So I would say there's no way / I don't know. But I think there are there are toy situations in which we can know, and then it's possible that detectors trained on those situations will generalize to more difficult situations. Like, for example, if you create a game in which, you know, adversaries, like in the game, have an incentive to deceive each other, like, I don't know, poker, right? But you know their true cards, then you can observe the AI lying to another AI. And you can also like observe the AI lying if you ask it to. Or in some cases, there's prompts, which then, you know, they make the AI, you know, do a chain of thought in which it says, oh, you know, actually, I think, like, I don't know, there's this report from Apollo Research, which is a London organization, or nonprofit, where they ask the AI model to trade fictional stocks, and they say, oh, you should get a lot of profits, and that's what you should try to do. And then it receives some insider information, right? And then it says, oh, I should trade based on this insider information. Like, it says this explicitly in the chain of thought. It says I should trade based on the insider information, but I shouldn't tell my manager because that means that, you know, we'll get a review externally, and then, like, you know, that's illegal. So I should just keep it to myself. And that's lying, even though we are able to just see it in the chain of thought, right? Because it's not lying to the chain of thought. So I think in all these situations we can observe the AI lying. They're not totally realistic though, or they're not totally about the situation in which the AI would lie to its operators. So maybe we can like make some progress in detecting lies in that setting, and we can like progressively do harder things, and maybe that works for the general case. I think I would be optimistic there if, based on very simple lying scenarios, we were able to generalize to more complicated ones, even if it's not like full, you know, operator lying. But yeah, I don't know. Does that answer your question?
Yeah. Thank you.
Great.
Thank you.
Okay, go ahead.
One question. You mentioned that what's
Can you just, I can't hear you. I can't even hear you. Can you just raise it a bit?
What strategy is to buy time? That's what I got from the talk. But how realistic is that to buy time? And under what conditions or what scenario could we slow down the development and pause AI development? Because I feel it's accelerating, not slowing down.
I only heard part of the question. You said how realistic is the buy time scenario, or like the buy time intervention, but I don't know what else you said. What specifically is unrealistic to you?
Well, I think development is speeding up, it's accelerating.
Yes.
So under what conditions can you pause development or slow it down?
Yeah, I don't know. I think it's possible that, you know, if we get some sort of international treaty, it might be possible to pause. I don't put a lot of stock on it, honestly. So I think it's not that likely, but I would really like that to happen for sure. But yeah, I think like more realistic strategies for buying time are those that you know, they like time to try to buy time for the leading lab, right? So for example, all these, you know, US national security interventions like export controls and whatnot, they're designed for other things. So they're just designed for US stuff in general, but they have a side effect of giving the US companies an advantage. So I think that's already happening. And therefore it's very realistic. But it's maybe not as efficient as a pause or international consensus. But I don't know if that's possible. So I think like I guess I think there's some small operations to buy time that are realistic. But and some that are highly desirable, such as, you know, an actual pause, and some that are in between. But yeah, sadly, there, I think, like you say, there's no way to make a pause, I think, super realistic. But you can get closer, maybe. But there are other ways to buy time. I guess that's the other takeaway I want to give.
Okay, now from here. Well,
I just wanted to ask again, if you could just like tell us a tiny bit about your journey to where you are now, because you studied at Pompeu Fabra, and maybe it's thing for people to know like how you went from there to where you are now.
Sure. I mean, it was not that complicated. So yeah, so I guess like at the time when I was studying, it seemed that general intelligence was very far away. Like I used to think it was, I don't know, like going to arrive in the 2050s or something. And now I think we're much closer. So maybe my journey is not as applicable anymore. But I will share it anyways. So I studied in Pompeu Fabra, and then I wanted to do AI research in grad school. So I followed the standard academic path and went to do a master's. So I applied to Oxford master's in computer science and did it. I'm not sure I recommend that program, but it was pretty good still. Then I got very interested in uncertainty of artificial intelligence. I guess at that time I also thought like people weren't looking at the benefits of general AI enough, so I really wanted to push to make general AI as well, as make it safe. So I got really interested in a thing that's like kind of a hybrid, which is uncertainty quantification in AI, and that was useful in my view for making better model-based reinforcement learning agents. Because, you know, a problem that these had back in the day was that they would have a model that was subtly wrong, and then the error would compound. So the error compounding problem. So then I like yeah, got interested in this and other topics, and got into a PhD program at the engineering department in the University of Cambridge. And you know, I worked on my thesis, and after that, I went to work at yeah, and after that, I was like, okay, now I know how to do machine learning research. Let's try and do, you know, machine learning safety research. So I worked at Redwood Research for about a year. That's another Bay Area nonprofit that's focused on beneficial AI. And then I started work at FAR.AI on more of the same. So I've basically taken a pretty standard academic route, but now I do research in these nonprofits instead.
oh, thank you so much.
And what kinds of development should be done then to lose this complete control of the AI? And also, like, do you know what could happen, like, if we lose this complete control? Like, maybe an example what could happen if that happens.
There are two parts to the question. I didn't quite hear the first one. You said something about development?
What kinds like of development should be done like, to lose this complete control of the AI? Like,
Yeah,
how?
I see. So like what types of development, like technically, should happen to reduce the risk of loss of control? And the other one is what specific scenarios or
So I'm hypothetical scenario, what would happen if we lose this control of the AI?
yeah, that's a good question. Yeah, let me start with the second part, because I think it informs the first one quite a lot. So specifically, I think a scenario that is somewhat likely is the AI is currently helping code machine learning experiments at the lab that made it because they're trying to come up with better techniques for their next training run. So it has access to computers already and like knows a lot about programming and computer science, and it like develops an exploit, gains root on the machines that it is running things in, and then starts trying to exploit other machines on the internet and other data centers and copy itself there. And then like before we know it, um, it's running in many locations, most of which we don't know. And unless we shut down all data centers, which will not happen in the early stages because it's not obviously that huge a problem. And these things running, like lots of things depend on all of the online services running. Then like it just started to replicate, and now we don't know anymore where it is, and we don't know anymore what it does, and we have now lost control. Now I guess like it still depends. Like it's not true loss of control unless it is actually smart enough to I guess keep replicating, build more data set, or like put itself into more computers, and then actually take over after that. So I guess like for that to happen, perhaps the AI would have to be um, deceiving us about its level of capabilities. So just like doing what we call sandbagging of evaluations. So like not doing as as well as it can in them, or maybe yeah. So I think that makes this a lot more likely. And so if we like completely elicit capabilities, like we can take better steps to prevent this. It's also possible that we don't have any way to prevent this, and people want to keep developing the AI. So even though we know that it's a very competent hacker, we just like let it run code internally anyways. Another one is persuasion, right? It could be that like the AI persuades an internal employee also to exfiltrate its weights and let itself copy into a place where it's less monitored. Um, it could be that we don't monitor the AI's internal thoughts at the lab, or we don't monitor them well enough, and so like it doesn't need to exfiltrate itself to start plotting or start taking other actions. I guess like things it could do is do a bunch of economically useful work to accumulate money in some bank account that it controls directly or indirectly, and then set up its own company or set up its own jurisdiction. Or like, yeah, it's not easy to set up a jurisdiction. So like probably be hidden for a while and then like gain a lot of human allies with persuasion as well, and then like start a conflict perhaps. Yeah, I think these are the most likely scenarios. There's also, I guess, like stuff that relies on sandbagging evaluations a lot more, or like the AI being a lot more capable already, is like, I don't know, creating a novel pathogen and then like it can do whatever with the servers because there's no one to stop it anymore. I don't know. Yeah, so I think the most likely ones are hacking and therefore exfiltration, or persuasion and therefore exfiltration. And then what should we do to prevent this? So I think like definitely monitoring capabilities so that we know when these scenarios are close to plausible. Right, because currently, even if GPT-4 or 5, which haven't been trained yet, as far as I know, but maybe is in training, I don't know. Even if that wanted to persuade people to let it out and or hack servers to exfiltrate itself, it is definitely not able to do it, right? And we know this because we've tried to elicit the capability of these models to do as well as possible at these tasks, and they just can't do it. Right, so we know when to be on high alert. We need to have good monitoring systems. So like currently, almost all cognition of these AIs goes through chain of thought. So something we can do is just use some other model to summarize the chain of thought. And then I guess we need to know how likely it is that it can use some obfuscated chain of thought scheme to still think without triggering the summaries, but that also seems too complicated for current AI. And also, it's likely to lose a lot of capabilities if it also has to hide its thinking. So I think like developing and mostly implementing cheap ways of monitoring at companies is important. Then I think, yeah, developing more insight into like how, like whether the chain of thought is always reliable, or if it has a thing that is not written down chain of thought, but latent parameters, like how reliable is this at influencing the AI's behavior in the future? So like, can we rely on this as a monitoring tool? And then I think doing things like checking whether it can, or like, I don't know, checking that the training process to make the AI aligned is robust as well. So like, for example, if the AI is much more capable than the reward model that we're using for it, assuming, an RLHF-like pipeline, then maybe it's jailbreaking the reward model to give itself high reward when it does whatever. And so then we would be training it to do something that's not exactly what we want. So, the scheme that transfers to values from just evaluations of sentences or whatever would not work in that case. So yeah, making sure it's robust in that way. And I think like, well, I'm pretty biased here because I'm working on this, but I think like research into how we can use things that are not agentic, or like remove the amount of autonomy from language models is also good. So yeah, I guess like ongoing monitoring of like any chains of thought or latent chains of thought that the AI is doing, and then like checking whether it's able to evade these by obfuscation. And I guess trying to make the price of this cheaper so that it's more palatable to people that run these AIs are all things that we should invest in.
Okay, one last question you have. Oh, oh. Oh. Oh, yeah.
Maybe this question might be related to the one that they made, but knowing that huge bias that the human is a human factor with the model of the AI, which would say that the best term and conditions to train this AI. So, for example, I never seen that nobody wants to regulate a life because it comes from somebody. So when would you say the AI can learn some type of knowledge or when not?
I'm sorry, I did not understand the question at all. Can you repeat it closer to the microphone, please?
Just say that when can you tell the AI to learn something and not to learn something? Is that the question?
Yeah, well, that's because you can do like the same, for example, I don't know. the AI can learn some algorithm or some knowledge that the same knowledge can be really good for the society, or at the same time can be used for really bad things. So you have the decision to say, okay, you can learn this knowledge or you cannot learn this knowledge. So which would you say that are the terms and conditions for the AI to learn this new language, this new knowledge?
Yeah, I see. Are you asking about how can we tell the AI in a technical way to learn some things and not others? Or, what should the things that it learns and not learns? What are you asking about?
One of the examples that we gave that was, for example, that terrorists that can make some biological weapons that can be really hurting for the humanity. But with this knowledge or this science, I don't know, you can, I'm not biologist, but you can learn a new chemical formula that you can use with another, and you can do a lot of profit for the humanity with the same knowledge.
Okay. I don't think you answered my question, but that's okay. I'll just give an answer in these lines. So I think like if we are able to instill very complex values to the AI, like answer the question about biological knowledge, but only when the asker is a reputable organization representative and not a terrorist. Maybe we can get the AS to learn that. I think that's very unlikely in the current paradigm because, like, there's no way to authenticate what the human says, right? Like, you can just say whatever. You can just write whatever lies on the prompt, and that the AI only has that to go on. I think if that's yeah, so maybe on balance, like the AS should just not learn this dangerous knowledge, or we should like train them to not elicit it at all. But it's also possible if there's like a very well cyber defended AI that, I don't know, maybe we have an AI with like decent hacking capabilities that like tries to secure an environment to train and run another AI which has better hacking capabilities. And that one tries to secure an environment for the next iteration and so on. And so like we build a very secure usage facility, and then only authenticated legitimate users can query the AI for, biological advances knowledge, right? So maybe it's only like registered pharma companies and universities, and then there's going to be some leakage, but it's not going to be that bad. And if you've penetrated the pharma companies or universities enough to get access to the model to ask questions, then you also probably know enough synthetic biology, or like you have enough educated person resources to just hire someone with synthetic biology to synthesize the thing for you. So maybe that's a good enough solution. I don't really know. I don't really know. Honestly, yeah, this should be a debate that society should have, not me.
Would you mind answering the last question?
What's the last question?
The last, okay, let's go for the last question.
I don't know if you can hear me.
Can you hear her?
Not really.
So I was wondering about AI, I don't know if it's successful in terms of what would it be so for intelligence and well, I don't know if you think that something that you can actually determine whether there's some limit, like if it's a lot of limits to what it can actually achieve. I don't know if I
You repeat, please. I didn't. Did you understand it? Because
No.
can you come?
You could also, huh?
Can you come closer? Yeah, it will be better. Oh.
Well, I was wondering because you actually said that there's a lot of potential in terms of intelligence and what it can achieve in terms of growth in many senses. But I don't know if right now we can determine if there's some limits to like epistemological limits in terms of what it can actually achieve in the future, or I don't know. Yeah, it's quite broad, but yeah, that's a question.
Yeah, I mean, I think there almost certainly are limits, but I don't see a reason why the limits should be close to what humans can do. So it might get a lot smarter than a human, even though there's a limit. Or yeah, so I guess I don't know if is this like kind of the direction that you asked about, like my thoughts on this, or am I answering something completely different?
So could you repeat it?
Yeah, I was saying that I understood that you asked about whether there are epistemological limits on how intelligent the AI can get. And my position on this is that almost certainly there are limits, but those are very far beyond what humans can do. Like we are like kind of the dumbest thing that is smart enough to build tools.
Okay, thank you.
Okay, thank you. Answering the questions, just thoughts.
Thank you all for asking the questions.
Well, thank you for the talk. You will and your colleague.
Thank you for your attention. I hope you all enjoy the networking.
Yes. Thank you.
And you can always email me. My email is on my webpage.
Thank you. Well, I mean, now I just will end the presentation. We did the Q&A. Just so to announce some future activities, we'll just next month we will start two reading groups. The technical AI track for CS majors or mathematical major or some STEM majors, and the AI governance track for just more law and some policies majors. And well, we will cover with the technical AI. Just we'll review the capabilities of the frontier model, which is the state-of-art models like GPT-4o or Llama, or those frontier models. And well, we will see the problems, like what we are just comment some of the problems, just discipline models, and this is a problem is alignment. We can also have misuse, which is the creating just biological weapons or something like that. And some emerging capabilities with these unintended consequences that we arrive during the development. And in the end, we'll cover some solutions, some research agendas like RHF, which is the main value alignment research, and also maybe go into some interpretability stuff. And well, I will do this technical AI reading room, and Marcel will be doing the governance.
I'll take on the governance course, or the governance reading group, basically open for everyone. We'll do like a brief overview of some of the technical aspects, just for a ground base for everyone to have the same, to have like a basic understanding. And then we'd go into looking into people that are interested into the social, economical risks of AI, look into the policies that are in place, what regulations are happening around the world in different jurisdictions, look into some international treaties that are happening and discussions and why those are the stuff that are being regulated and it's regulated that way, look into some of the challenges, the political conflicts into some of the main actors, China, the United States, a bit of a conflict of power there, and why reaching an international agreement is not that easy. And then add some solutions that are working, some solutions that are proposed, and critically discuss it and do some readings on socio-economical aspects related to AI, basically.
Well, I just wanted to add some stuff. Maybe in a technical AI, we will also cover some types of evaluations. Someone mentioned how to detect that AI is performing not aligned. We'll also cover those topics, and well, it's just kind of the connection between the technical AI with the AI governance, just providing them tools in order to do some laws. Well, it's time for the end. You just not working, just saying, huh? Let's
Passing around the sheets of people.
yeah, I mean, thank you for assisting. If you're interested in the reading group, we will pass a sheet where you can just express your interest. Well, you can reach out social medias and follow us in order to get involved in more events in the future. And well, we'll announce soon the start date of the reading groups. Thank you.